Hi, everyone. My name is Brenna. And before I did what I do now, I was a data engineer and building pipelines, managing stakeholder expectations. And I created this talk out of a frustrating experience that seemed to happen to me over and over again. I'd build a perfectly working batch pipeline, and some time along the road, months or years later, someone would ask me to re-architect it to streaming as if that was always better. This talk is about finding the middle ground between batch and real-time processing, when to use one or the other, and how to architect for both. And I hope that I can save at least one person from the frustration that I fell into. So get into it. The question you're probably asking yourself is why you should believe me. I've been a data engineer for about 12 plus years, and MinIO AI Store is the standard for object storage on-prem. We've got over 2 billion and growing Docker pulls worldwide. And in short, we filled a lot of data lakehouses and spent a lot of time talking and listening to our customers and understanding what works and what doesn't scale. We're the most highly awarded object storage software on the market, and we don't take that developer goodwill for granted. That's just why we're always happy to come to these things and share what we've learned with the community. And back to my main argument, which is that batch is still good enough. So I've seen and personally felt a lot of pressure to replace batch pipelines with streaming ones, and sometimes that's valid, but a lot of the time it's not. Batch jobs are often simpler, they're easier to recover, they're much more efficient to run. And the reality is that in all aspects of a data stack, simpler means scalable. And then on the topic of scale, let's be clear, batch doesn't mean small. I've worked for and seen batch pipelines that move petabytes of data overnight. It's just that no one needs that data until the morning. And big doesn't require real time, it just requires throughput. So the real question shouldn't be, can we stream this? It should be, do we need to? And if the answer is no, then batch is still good enough. But until it isn't. And there's always a but in data infrastructure. So you can't shoehorn batch into latency sensitive workloads, of course. So the question from there becomes when to use what. And batches should be your go-to for high volume, non-urgent workloads. Think things like daily reporting, model training, warehouse refreshes. They work great when you can tolerate some delay. You can schedule pipelines during off-peak hours, thereby optimizing your compute, and you can avoid the complexity of event handling altogether with batch pipelines. You want to use batch when speed isn't critical and efficiency matters more. Microbatch is a really great middle ground between the two options. You get lower latency than with batch, but without the complexity of an always-on, fully streaming system. In this space, you can think of things like Spark structured streaming or Flink with mini batches. It's great for dashboards or near real-time ingestion. Any case where getting your data in a minute or in an hour is good enough, micro batches can step in here. Now, true streaming. This is for event-driven, low latency workloads. You guys all know what that means. Fraud detection, anomaly detection, alerting. Anything where you need to react to your data or a machine needs to react to your data immediately. But of course, and the whole point of this talk is that the speed comes with a cost. So you have to be able to handle scale, ordering, bursty traffic. It's obviously going to be more complex. But when you need it, you need it. And that's where streaming makes sense. So, none of these models are mutually exclusive. In a modern stack, you'll likely use all three. The key is picking the right one for the right workload. And so we've talked about the different options for your pipelines. The next natural question, since we're talking about filling up data lakehouses, is which open table format fits which workload best? So all three of the major formats, Iceberg, Delta Lake, and Hootie, they all support ACID transactions, schema evolution, and time travel, but they all have very different design goals, different optimization paths, and very different engine integrations. And choosing the right format is not going to make or break your ingestion model, but it can and it will shape things like engine compatibility, what you can use to query over your object store, performance, and your tuning experience, how long you're going to spend fiddling with dials. So Iceberg, you've probably heard a lot about, I know you've heard a lot about Iceberg in this conference, and it's for good reason. It's backed by a super broad ecosystem. Trino, Spark, Flink, Dremio, and even Snowflake can read and write Iceberg tables. Query planning is simplified with things like hidden partitioning and partition evolution. You can get some really cool things like table versioning and schema evolution. And now, with the most recent release, there's even some new additions to the project that were originally implemented in Delta Lake, like deletion vectors, row lineage tracking, and variant support types for things like JSON. So if you want an open table format that's going to integrate with everything, that's really great for large volumes of data, Iceberg is a clear winner for your workloads. Delta Lake. So Delta Lake is very deeply integrated in the Databricks ecosystem. That's kind of a no-brainer. If you're already all in on Spark or all in on Databricks, it's a great choice. You'll benefit from some really great features like liquid clustering and photon acceleration that make the performance on Delta Lake super fast. You're going to have a great experience. And my takeaway from this conference is that in the future, we're going to see the best of both Iceberg and Delta Lake coming together. And I think that's a really great news for end users like us and for both projects. So if you're all in on Databricks, Delta is a great default. Hudi was optimized for streaming and incremental workloads. It was designed for high frequency ingestion, things like CDC, IoT, log data, that kind of thing. And it offers some really interesting things like flexible indexing, Bloom filters, global indexes. But I think Hudi's strength is also a limitation. So it excels with really specific workloads, and that means by its nature, it's going to be less flexible with things like multi-engine support and multi-purpose environments. So I think if you're just doing a pure streaming ingestion and you're from the Hadoop ecosystem and maybe holding on to still very relevant catalogs like Hive, Hudi can shine. Otherwise, I think it's a narrower fit. And the reality is there's no one-size-fits-all answer. But I think once you understand your workload patterns, your engine preferences, the right choices are going to become clear to you. And you've heard during this conference that object storage has become primary storage for query engines. I want you to think of Mother Duck, Tigris, Bowplan, TurboPuffer. They're all here talking about their query engines that sit on top of object storage. But this query layer needs data to operate over. And regardless of whether you batch or stream your pipelines to do that, performance is critical. So I know this is a little bit lower in the data stack than what you've been hearing in the last few days, but your storage layer will predict the performance of your pipelines. Bottlenecks in this foundational layer will affect everything up the stack, and cracks in your infrastructure will only become more egregious as your data volume grows. And nobody has any less data than they did the day before. It's always growing. You can't throw disks at disintegrating or inappropriate infrastructure. You have to make good choices from the start, especially when you're building for scale, which everybody who's doing AI or building a data lakehouse has to. So let's talk about what I mean by that. We'll start with performance and scale. It's really easy to be fast at 100 terabytes. Everybody can be fast at 100 terabytes, but it's a lot harder at 100 petabytes, especially when you're dealing with millions of small files or deeply parallel workloads like the kind we see with AI and data lakehouse workloads. Simple and scale by design. So by that I mean we hear from our customers that a lot of other storage systems fall apart at about 30 petabytes, and that's not a lot of data. And we usually hear this from them because these other storage platforms are built around gateway or have a metadata database bottleneck. Layering S3 on top of file and block might seem like a modern choice, might seem like an S3 compatible choice, but at scale, it does break down. So a flat distributed metadata architecture will avoid these bottlenecks, and most importantly, they scale cleanly. So NVMe first, you can't get the performance modern workloads like AI and data lakehouses require from spinning disks. And that's kind of a hot take, but you can get them from commodity hardware, NVMe off the shelf. Modern object storage will assume flash, where parallelism or bandwidths that can saturate 100 gig E or 200 gig E. But it's not just about the hardware. The storage software has to keep up. So if your object store can't push line rate, you're setting yourself to re-architect in a few years, and data, as we all know, turns out to be very difficult to move once you put it somewhere. So pick the right choice from the beginning. And I hope that you've come away from this talk with the idea that both batch and streaming are fine. And you should just pick one that matches your workloads, and your object storage should allow you to do that. So we see, people that experience massive sequential writes for things like model training, and at the same time, they have small objects pouring in from Kafka or IoT. Your object storage needs to be able to handle both small and large objects. And this is all where high-performance object storage really proves its value. So that brings us to one of the most powerful tools we have to handle performance at scale, which is S3 over RDMA. And it's especially powerful for batch or micro batch or very high volume streaming workloads, because RDMA over converged Ethernet lets us move at terabyte speeds over standard Ethernet infrastructure. So that's a critical piece of it. It's cost effective, it's scalable, it's future proof. It's also, because it's not a new technology, has multi-vendor support and is already widely adopted. You probably heard some of NVIDIA's announcements over S3 RDMA. It's a standard that is accepted in our community. And we're big fans of standards, which is why MinIO so closely conforms to the S3 API and why we support open table formats like Hudi and Delta Lake and Iceberg. When we as vendors can circle around a common standard, we can spend our time focusing on what really drives the needle for our customers. And our customers can hire for, train for, and maintain without a specialized or proprietary skill set. I'm a big believer that skill sets in a modern stack should be transferable. You should be able to take what you learned from a product or a system or an architecture and bring it to your next architecture or role or idea or company. Standards are a big win for the whole community. And in the middle, you see why that matters. When you're operating over 400 or 800 gig E speeds, RDMA helps deliver the kind of throughput and low latency that you need for training models or processing real-time analytics at scale. RDMA bypasses the TCP IP stack entirely. It skips over the CPU and goes right to the GPU, and it moves data straight from memory to memory. So it obviously will cut CPU overhead, and unlock zero copy transfer. It's overall going to be faster and more efficient. So this is a speed run through why batch and streaming both make sense for modern workloads. And thank you for your time. It's been healing for me. I hope it's helpful to you. If you'd like to check us out, we're at min.io. It's really easy to deploy and fast to see value from. May your compute and storage always be right-sized and happy streaming or batching or both.